All right, ladies and gentlemen, good evening, good morning, or whenever it is that you're watching this. Welcome back. Excuse the quality. I meant to do it on my regular camera, but I'm traveling and the computer I brought with me doesn't have micro SD, so we'll make do with what we have. I wanted to get something out as a follow up to that previous installation video for AutoGPT. And we'll kind of go over the limitations of large language models more broadly and AutoGPT specifically as well. And we'll kind of be structuring this in terms of, as you can kind of see on the screen, we'll be going over what are the basic terminologies, right? What is a GPT? What are the various other terms that have kind of popped up surrounding the field of large language models and GPTs. And then we'll get into kind of the limitations of these models and what you kind of can't do with them right now. And we'll also discuss ways that we're addressing these limitations and how these things might change going forward into the future. So we may as well start with the beginning, which is, what is a GPT? A GPT is a generative pre-trained transformer. Okay, and you kind of break down each of these kind of words there. So generative means that it produces outputs that are new. Okay, and pre-trained suggests that it starts with inputs that are old. Right, it takes a really massive data set. In the case of like GPT-4, for instance, nigh on the entire internet, basically. And they kind of take this input and they process it. This is the pre-training part, and they are able to generate things with that. The natural language processing part of that includes techniques like where you take many of these large data sets, you take sentences, mask certain parts of it, and have them try and generate what's missing. Essentially, it's at a most fundamental level, what they're training the neural networks to do is to guess the next word. That's the basic unit of what is going on there, which would be reductive to say that it is simply a thing that is guessing the next word, because ultimately there are things that we did not train it for that it can do. Abilities like coding, for instance, we never trained it to code, but it can code. That's actually something that emerged by itself. There's a couple of examples of these types of emergent behaviors where we didn't train it to do that, but it kind of picked that up. So it started off as guess the next word, but becoming exceedingly good at this task for whatever reason seems to cause these emergent behaviors to arise. What then, and this was something that Google came up with some years ago. So this is based on a concept that they came up with, the GPT. AutoGPT is basically just taking this GPT that you have, this large language model, and giving it access to other versions of itself. It can start other versions of itself, or 3.5, GPT 3.5 agents. I can use that to kind of self-query almost. If it runs into any problems, taking care of things itself, it can then make other agents to kind of delegate the workflow. The idea is that you kind of give it something to do, and it will just keep working until that thing is done. Hugging GPT is basically just where you hook a large language model up to Hugging Face. Hugging Face is this AI model and machine learning kind of website that has all these tools that are available, giving the GPT access to that so that they can do tasks using these extra tools is Hugging GPT. Memory GPT is this concept. It's not really like a specific like GPT that's out. It's like the concept of adding persistent memory between sessions and having more short-term memory as well in the GPT. One thing we are going to talk about later is the context window. Memory is a big limitation with AutoGPT or GPT-4. Memory GPT refers to various different solutions that could circumvent that issue. Chaos GPT, haha. As soon as we came out with GPT-4, somebody decided, let's connect this to the internet and then tell it to do as much damage to humanity as possible, which is what Chaos GPT is. That is existing. So far, society still exists, so it does not seem to be doing a very good job, but it just kind of demonstrates the idea that that is something people can and will absolutely do. So let's jump into the limitations here, okay? First off, these large language models, GPT-4, AutoGPT, they're limited by their training data. What they've seen is what they know. They get confused when you go outside of their training data. And unfortunately, when you do that, it doesn't simply result in a situation always where they tell you that they don't know. Sometimes they will. The accuracy of GPT-4 is up to like 81% or something like that. But sometimes a not insignificant amount of the time, they will confidently tell you absolutely the wrong thing. Completely the wrong thing. And so that's the issue with what they call hallucinations. They'll just come up with stuff that isn't true and is nowhere in their training data, and we don't know where it came from. But there's some possibilities for where they came from. We'll go into that in a second. But it's a known issue and a real problematic issue about these confident errors. One time they've tried this with medical stuff, and when the patient, it didn't know how to deal with the patient going forward, it just kind of told the patient to kill himself. So confident errors, choosing the wrong thing going forward, is a really big issue, especially for system critical applications. Domain-specific knowledge also, it's limited by its training set. So that general training set, however large, may miss very domain-specific things. And, there's already multiple different potential solutions around this. You generally do some form of knowledge injection is what they call it. This can be done either at the structural level, where you scrape or like you actually train the algorithm differently, or you just take a trained algorithm and at the level of user input, adjust it from there. There's pros and cons to each, but generally you knowledge inject it. Going forward, you can kind of think of the limitations in terms of the octopus scenario, as they call it. So if you were talking to another person and you were kind of using old-timey cable run underneath the ocean, and an octopus were listening in through the cable, and they were particularly good at statistical learning, okay? This octopus learned English. It learned the structure of the language, it learned the words, it learned everything to make English and make it seem real. But it doesn't understand what exactly these words mean, right? Especially since there's a lot of concepts that it couldn't possibly have any real idea of. If you ask it what the weather is right now, it's gonna get caught up by that. Without some kind of specific oracle, it has no way of knowing this type of thing. And so there's kind of, and also the idea of hail or rain or wetness, the concept of wetness. There's a lot of things that it can't inherently understand. And when conversing about various concepts, it may come up short. When you're conversing with ChatGPT, you'll probably notice that it kind of doesn't understand certain things sometimes. And that's likely where that's coming from. The other issue is communicative intent, right? The octopus doesn't speak any language natively by default, right? But it's taking in these words. And so communicative intent, it doesn't necessarily understand the idea that humans use language for certain purposes, like asking you to do something or to, ask for help or making a joke or whatever, and for informational purposes. It doesn't really quite naturally understand communicative intent. Part of the training process for GPT-4 and these more modern things made by larger companies is what we call RLHF, reinforcement learning with human feedback. This is basically literally having it produce outputs and then having a human manually go in there and choose which is the more desirable and preferential output. And this can really help with the communicative intent problem. The issue, though, is that it's a brute force tactic that is very expensive to do. It takes manpower. You're just hiring a dude to train it, manually. You encode that basically into the training and the architecture of the model, and that can make it really improved in terms of the communicative intent. And we also mentioned earlier about the context window. Okay, so context window is how much text the model is actually able to hold in its head while it's conversing to you. If you were to, so it's expressed in terms of tokens. GPT-3, 4,000 token context window. A token is like 0.7 words. It's like 3/4 of a word or something like that. And so GPT-4 was the publicly available model is up to 8,000 tokens. The cutting edge model that not everyone has access to, including myself, unfortunately, is 32,000 tokens, which is significantly more. We'll talk about RMT in a second as well. But the importance of the context window is that it unlocks a lot of applications. Because if you need more than a certain amount to do whatever you want to do, it's going to start forgetting what it's doing. It's like a goldfish. 8,000 tokens isn't that much. You can still do a lot with 8,000 tokens, but there's a lot that you can't do. If you remember 2 videos ago, I was talking about what I was doing with AutoGPT. I was basically trying to make an autonomous game engine. That is a huge project, and we can't do that with 8,000 tokens. You couldn't even do that with 32,000, I don't think. There's something called RMT, Recursive Model Training, that was just published recently, that theoretically could get GPT-4 up to 2 million tokens, which is ridiculous, dramatic improvement over 32,000. 2 million tokens unlocks a lot of things. Larger projects will be possible. If you've noticed anything with larger projects, if you've done them, they don't get done. AutoGPT, this is a limitation that AutoGPT absolutely has. You might notice that in terms of AutoGPT projects that specifically require AutoGPT that have been released, it's very little success in terms of this AutoGPT. It's touted as this big thing, but most of the things that it's been able to do are things that, with some exceptions, like the online to-do list type stuff. There's certain things that are unique to AutoGPT that you can only kind of do with that. As of right now, they're actually bringing out a hooked up chat GPT that's online. So that will kind of obviate most of AutoGPT unless we had a bigger context window. They are going to release a 32,000 context window, and if they do RMT, recursive model training, they can maybe even get to millions. That would potentially allow you to do an automated game engine. If you could get to 2 million tokens, that would be huge. That would be enormous. That would unlock a lot of applications. Also, right now, a lot of these large language models have difficulty with temporal context. The idea that something was the case one time is no longer the case now and could be different in the future. Temporal context is something that they do struggle with a little bit right now. And finally, mathematics as well. They can do single-digit calculations reasonably. They suck at word problems, and they suck at more complex stuff than single digits. Anything more complex than that, a calculator is better. Just a regular calculator. Now, something like a Wolfram Alpha plugin would pretty much solve that issue in one fell swoop. But as of right now, you don't ask GPT-4 math problems. It just doesn't even make any sense. At a basic level, it just sucks for that. So yeah, in general, those are the limitations that I've identified so far. There's likely a couple more in there. Those are the major ones. Point out in the comments if I've missed any, if you wanted to throw those in there. But, feel free to ask any questions you want down there. Like and subscribe if you got any value. And, thanks for watching to the end if you actually made it this far. Peace, and I'll see you in the next one.